Okay, boss, here we go. I've got your two formulas that we're going to be using, at least for the first two, 13 and 14. This one I got to do a little bit more studying on just because there's something tricky going on in there. Well, we'll deal with that later. But anyway, this is future value. This is like if you're plugging money in at a certain amount every month or every week or whatever, this is the formula you use, and you want to find out how much you're going to have at the end of that. This one, the present value, is if you're, this is usually used for like loans, mortgages. If you're borrowing in a certain amount for, whatever, you're going to borrow $300,000, that would be 300,000. This is how much you're going to pay every month, and this is going to be all the, where the interest rate comes in. And all these, N is the total number of payments that you make, and I is the interest per pay period. So with this first one, I just texted you about if it's ordinary or not. So if it's 0.4% as a decimal, that's 0.004. So if you divide that by how many pay periods there are, in other words, he's paying in 26 times a year. I took 0.004 and divided it by 0.26, and I got this. And this isn't the full decimal that came on the calculator, and I'm not sure how touchy your homework thing is here, but when I do this on the calculator, I'm going to use all the decimals that the calculator gave me to keep that really accurate, because it matters a lot when something gets multiplied together like 208 times. Little errors will become big errors. Anyway, and then N is 26 payments per year. 26 payments per year for 8 years is 208 payments. So all I'm going to do is drop the numbers in, and we'll see what we get. So R is 533 times 1 plus this I number. I'm not going to write all those decimals. And then we're going to raise it up to the 208th power. Then we're going to subtract 1 and then divide by that I number. So I'm just going to get that number. I'm going to get, maybe just so you can follow along, I'll do these numbers kind of carefully on my calculator in little stages. So for this I number, plus 1 raised to the 208th power, I got this decimal here. It's just a little bit bigger than 1. We're going to subtract 1 from that, so it's just going to be this 0.0325 part of that thing. Multiply that by 533 and then divide by I. Okay, so I just ran those numbers out and multiplied it through 533 times this gives me 17.33, blah, blah, blah. Divided that by I, which again is right up here, which I stored in the calculator. If you don't know how to store a number in the calculator, it's a good thing to know how to do. Maybe I can show you that later. Anyway, I got 112,648.0927, which we would just round to 0.09. But I think the question is just asking how much interest you'll earn. So basically, this is how much money you're going to get by plugging it in there. But you got to remember, you put $533 in the bank 26 times a year for 8 years. So let's find out how much that would be if you just, didn't have any interest at all. So if I do 533 times 26 times 8, that's 110,864 exactly. So the interest would be the difference between these two, the 112,648.0927. This number minus that number would be how much was in interest. So I'm going to do that 112,648.0927 minus that 110,000 number, and we get the interest amount, which is 1784.0927. So I would round that to 1784.09. So hopefully, if you put that in here and hit the submit button, hopefully it'll be a right answer. If it's not, I don't know what the hell to do. That's the only way I know how to do that problem. So now we can move on to this other one, number 14. This one's actually pretty easy. It's just going to be a straight up following this formula. So in this one, the only trick is they're doing the mortgage, or the house is 205,888, but they have to put a down payment of 9% down. So we have to find out how much they're actually going to borrow. So by putting down payment, that means they're actually going to give the bank cash up front for 9% of the 205,888 number. So let's find out what 0.09 times 205,888 is. And that is 0.09 times 205,888 is $18,529.92. So they don't have to borrow that much because they're giving the bank that much right up front. So if we subtract this amount here from the full price of the house, if we do 205,888 minus that amount, they're going to borrow 187,358.08. So that's the amount right there. That is like the present value. That's how much they're going to borrow right now. And what we're going to find out is how much they're going to have to pay every month. And then once we know how much they pay every month, we can figure out how much they're going to pay over the 20-year of the loan. And then once we do that, we'll have the total amount they paid compared to this present value of what they really just needed, and the difference between those two will be how much they did in interest. So let's do that. So present value is this 187,358.08, and that's equal to the monthly payment, which is R, 1 minus 1 plus I. Now for I, for this problem, it is a 3.3% annual rate, so 3.3% is 0.033, and that's like the rate, but the I is the rate divided by how many pay periods there are. That's going to pay once a month, so it'll be 0.033 divided by 12. So if we get that number, we get 0.00275. So that's our I number. If you want to store that in your calculator, all you have to do is hit the store key, which is right above the on key, and then you can pick a letter to store it to. If you hit the alpha key and the x squared, that's I. I usually just store it to I, that way I don't have to type that all the time. So anyway, we can go back to here and say this is going to be 0.00275. Put a fraction bar and put 0.00275 there. And this part right here is going to be raised to the negative nth power. And n is this one is 20 years, 12 months of the year. So 20 times 12 is 240 payments. So this is going to be raised to the negative 240th. So I'm going to run these numbers. I think I'm going to just do this on my calculator, this whole thing here, just carefully. 1 plus 0.00275, get that number. Raise that number to the negative 240th, get that number. Do 1 minus that answer, get that number, and divide that answer by 0.0275. If you do this stuff carefully on the calculator, you can't really screw it up. Alright, so I got that number of all this stuff just turned out to be 175. Usually those numbers turn out to be somewhere between, in the upper 80s, 90s, somewhere right up there to like 200 or so, depending on what the interest rate is. Anyway, all we have to do to get R by itself is divide both sides by this 175 number, blah, blah, blah. Divide this by the 175 point blah, 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 and we're going to get our R value, which is a monthly payment. So 187,358.08 divided by that answer we just got is 1067.445, which we should probably round to the nearest cent. That's what the bank will do, I think. So 1067.45. That's how much we're going to pay every month. So we're almost there, because if you take that and pay that money to the bank every month for 20 years, that's going to be multiplied by, so I'll just put times 240 payments, 20 months, 20 years times 12 months a year is 240 payments. We get a total payout to the bank of 256,186.84. I rounded up. It's 0.8399. So that's how much they paid to the bank. But this 187 is how much they borrowed. So the interest would be the difference between those two. So the number I get doing that subtraction is 68,828.76. Again, it was 0.7599, so I rounded up to 0.76. So hopefully put that number in here, and you should be good to go. But notice the whole idea is find out what the monthly payment is, and then figure out what the total payment's going to be by taking that monthly payment, multiplying it by how many total payments there are, and that's the total payment to the bank, and then whatever the difference is between that and how much you borrowed, that's the interest that you paid. Okay, I'm kind of guessing a little bit on this problem because it's asking about what's the balance going to be halfway through the term. So I think the way to do this is find out the total amount that we're going to have to pay based on these conditions here. The 30-year mortgage, $155,807 borrowed, 5.7 annual interest rate. So I figured out the I value for that, just took it and divided it by 12 because the payments are going to be monthly. Get that number for I. And the total number of payments is 30 years, 12 months a year is 360 payments. So we're going to plug these numbers in and get R, and that's going to be your monthly payment. Because this is this number, and all this stuff we have, and what's going to be given is our monthly mortgage payment. Once we have that, we'll know the total amount that we're going to pay to the bank, which is going to be a crap ton. It's going to be a lot more than the 155. And then we can just kind of divide that by 2, and that should be how much we'd have paid halfway through. So let's drop the numbers in where they belong. PV is this 155,807. That's equal to R, which we don't know. 1 minus 1 plus 0.00475 raised up to the negative 360th all over 0.00475. So I'm going to get this number on the calculator. Okay, so you can now catch up on my work. Got this number, subtracted 1 from it, and got this 0.818 number, divided that by 0.00475, and got 172.294. And then, so 155,807 equals R times 172, divided both sides by the 172.294, yada, yada, yada. And you get $904.30 a month. So, now, thinking about this, we're going to pay $904.30 every month for 360 months. And that'll be the total balance that we're going to pay to the bank. So if I take that amount and times it by 360, that is $325,549.62 with a little rounding there at the end. So that's the total amount that you're going to pay. So halfway through that, we just divide this by half, and that's going to be how much you will have left. So I'm just going to divide that answer by 2 and get $162,774.81. Now, that might strike you as kind of funny in that you've been paying for 15 years and you owe more than you started. That really seems crazy. You don't really owe more than you started because the principal left. In other words, how much is just left on this wouldn't be all 155, but you pay so much in interest when these interest rates get a little bit higher like that, that you have more left on the balance of the loan than when you started. because they know how much interest you're going to pay for the whole thing. So I think that's the answer they're looking for, because it just says what's the remaining balance. There could be something where, like when you look at these amortization schedules, and after year one, you will have paid a whole bunch of money. Let's say you paid $904. 12 times 904 times 12 is $10,848 about. But what they do is only a portion of that gets paid towards your the principal, the amount that you actually borrowed. If they're asking for that, what amount of this 155,807 is left after halfway through, I don't know, because I probably look up some formula on the internet to tell me that. But all I did was find out the total amount you're going to pay, and then how much of that's going to be left halfway through. So hopefully that's the answer they're looking for. I don't have a formula at my disposal that would figure out what percentage of this interest, of this total payment that you did during the first year, gets applied toward the principal of this and what gets applied to the interest. The only thing I know is, like, just anecdotally from having done this myself, is that at the beginning of the loan, most of your money goes toward the interest, and toward the end of the loan, most of it's going to pay off the principal. So that's all I got. Hopefully this is helpful to you. If not, I'm pretty damn sure the first two problems are right. This one I'm not quite sure, but there you go.